Hi everyone, welcome to the NARUC-NASEO Microgrid State Working Group webinar. I'll give us just a minute while attendees are trickling in. So in the interest of time, we'll get started. Again, welcome to the NARUC-NASEO Microgrid State Working Group webinar. This month's topic is microgrids for low and medium income communities, and we're very excited to have three excellent speakers joining us today. On behalf of NASEO and NARUC, I would also like to thank the U.S. Department of Energy and the Office of Electricity for supporting our Microgrid State Working Group and this webinar. Next slide, please. And before we begin, just a quick note on housekeeping. Everybody is muted, but if you'd like to ask questions, you have two options. There's a Q&A button where you can enter your questions, or there should also be a chat function where you can also add questions if you'd like. Next slide, please. This is today's agenda. I will turn it over to Commissioner Mary Throne from the Wyoming Public Service Commission, who has graciously agreed to moderate this excellent panel, and she will introduce the speakers. We'll hear from our three speakers, then we'll have a Q&A period with your questions that you please enter in the chat or Q&A box. And then from 3 to 3:30, we will have our Microgrid State Working Group meeting for members only. So with that, Commissioner Throne, the floor is yours.
Thank you so much, Kirsten, and thank you to our speakers for being here. We have a great panel this afternoon. First up, we have Brandon Bowser, who is the Energy Resilience Program Manager with the Maryland Energy Administration. Prior to his current role, he was the Associate Energy Manager for Resource Energy, which is a commercial real estate consulting firm. There, he managed a team of energy analysts in the utility redistribution department. In addition to his personnel management duties, Brandon performed utility consumption and cost recovery analysis on a diverse portfolio of commercial retail properties across the United States. Brandon has also previously served at MEA, during which time he managed the commercial and industrial low to moderate income energy efficiency and clean energy grant programs. He holds master's degrees in finance and a bachelor's degree in energy business and finance, both from Penn State. Stephanie Prestol is the Deputy Director of the Housing Initiative Partnership. She has more than 20 years of community development experience, and Stephanie has created a HIP single family acquisition rehab program. She plays a leadership role with HIP's multifamily development and manages HIP's resident services program located in each of its apartment communities. She was the project manager for HIP's Mount Rainier Artists Apartments, which received 7 awards for its innovation and green features. She has also worked with several large for-profit developers and joint venture relationships to develop 200 units of affordable multi-family housing. Prior to joining HIP, Stephanie was research director for the Enterprise Community Partners, and in this position, she researched the best practices in areas of finance development, supportive housing, community planning, safety, and organizational development. Stephanie earned a BA degree from St. Olaf College and a Master's of Real Estate from Johns Hopkins University. Finally, our third panelist is Sequoia Cross, Chief Operating Officer for SimpliPhi Power. Prior to joining SimpliPhi in 2019, she worked for D-Grid Energy LLC as a solar engineer and operations manager, deploying large-scale solar refrigeration systems globally. Prior to D-Grid, she was CEO and co-owner of Tamarack Solar Products and Backwoods Solar. She was instrumental in growing and scaling those businesses. Before that, she was VP of Operations at AEE Solar. Sequoia has a passion for improving basic human needs through access to energy and is a member of Energy Access Practitioner Network for the United Nations Sustainable Energy for All initiative and also for the Alliance for Rural Electrification. She is a graduate of Humboldt State University. And with that, I will turn it over to Brandon.
Thank you, Commissioner Throne, Kirsten, and all of the NASEO staff for having me here today. I definitely appreciate the opportunity to talk about some of the stuff we've been up to when it comes to energy resiliency in low to moderate income communities. I kind of have, it's sort of a co-presentation, if you will. My presentation will set the stage for Stephanie to talk a little bit more about the Housing Initiative Partnership Project, which is a really innovative low to moderate income community that's incorporating a microgrid that came through our agency's Resilient Maryland program these past couple of years. So that's the focus of my presentation on how we got behind this project, the programs that helped incentivize it, and where it's headed. So without further ado, next slide, please. And there's a couple animations on there. You might have to click to get everything up. Excellent. Thank you. And so MEA, who are we? What do we do? We are the State Energy Office for Maryland. We're known as the custodian of the Strategic Energy Investment Fund, or the SEIF as we call it. The SEIF is the fund that funds all of our energy programs at the agency. We have a few different funding sources, but this is the main one. To give you some background on the SEIF, it receives proceeds from the Regional Greenhouse Gas Initiative. And so we take those funds and we incent energy efficiency, renewable energy, and energy resilience projects, of which the one we're talking about today is a recipient of those funds. So as you can see, we're focused on all things when it comes to optimizing energy in our state across all different economic sectors. LMI is definitely one we're really focused on, especially now. We also advise the governor on energy policy, and we implement energy policy once it becomes legislation that goes into law. So that's who we are, the Maryland Energy Administration. Next slide, please. So let's talk a little bit about the Housing Initiative Partnership Fairmount Heights Microgrid project. So it is a block of 6 to-be constructed homes. So this is going to be new construction. That they're going to incorporate a grid interactive microgrid, and it's a really interesting configuration. It's bringing in some innovative technologies and a setup that we haven't quite seen in many places before. It will be offered exclusively to low to moderate income Marylanders, so that is one thing we're really excited about this. So new construction, efficient energy, clean energy. All of this is coming together to enhance equity for our LMI community, which is so exciting. But the way that it's going to be set up, and Stephanie will talk to you a little bit about this in more detail, is there's going to be a solar PV array on each home, and it's going to be paired with individual front of the meter. They're called block boxes. It's a storage, so there's battery storage inside of this thing, as well as a microgrid control system. So it very much looks like a box. It's made by Amera Technologies. They've deployed this technology in a few other places around the country. In Florida, there's also a military base where they showed the proof of concept. That's EMERA. If anyone's curious and want to see what that technology is, you can look them up and learn a little bit more. So these individual systems with the behind the meter PV in front of the meter storage with controller will also work with a centralized battery bank that will, and this whole thing will allow all of this energy to be shared between each home in both blue sky and grid outage conditions. So as I said, yeah, again, it's offered exclusively to LMI Marylanders. And what's really cool about this project is that it is a collaborative effort between 3 key stakeholders, those being HIP, Housing Initiative Partnership, the utility PEPCO, and then obviously Amera Technologies are all involved. The 3 of them are working together to bring this concept into reality. And we're very excited to see the utility involvement because it's one of the first big examples of utilities taking a leading role in incorporating DER systems into their own planning. Because given the fact that it's grid interactive, so it can help the grid in times of high demand, it can be leveraged as a grid asset. So it's more than just a microgrid, it's helping the grid at large and this community. So it's active utility engagement and smart grid planning, which we're very excited to see. So that's some background on the project. I'd next like to talk to you about sort of the support that we have in terms of the grants that we've issued to it. So we have 2 of them, as I said. They initially received about an almost $80,000 grant for the feasibility analysis, planning, and design through our inaugural Resilient Maryland program in fiscal year 2020. This analysis that we helped fund paved the way to getting toward a more finalized system design that has one interesting thing that we saw in the designs that we're getting from HIP is that this configuration has a very high replicability and scalability potential. So we think it can be done in other places. We'll see more as it's actually implemented, but right now it's presenting as a very highly replicable and scalable model. So from there, because it's so innovative and it incorporates this block box technology that's in front of the meter, which allows the utility to sort of manage all this power, it was an innovative approach to integrating a microgrid. And because of that, we actually issued it a $200,000 capital support award to help with the implementation. When we get highly innovative projects that are market transformative, innovative, market transformative, what have you, something different than what we normally see. If the conditions are right and our funding allows, we can issue custom grant awards. It doesn't happen often, but when we get gems like this one, we definitely want to get behind them. And so that's what allowed us to go forward with this unique capital support award. Next slide, please. So let me go back to Resilient Maryland to give you sort of an overview on what the program is and why we decided to start it. We, of course, being around, this is our 30-year anniversary, by the way, so we've been around for 30 years as an official state agency. And as you can well imagine, over that time frame, we've worked with a whole list of various grantees, applicants, stakeholders, industry advocates. And so we've been, walking in real time with the energy industry to see how it develops. And we want to make sure that our incentive programs and our initiatives are actively responding to the needs of the industry. So we're actively engaged in our state's energy landscape. And one thing that we've heard, especially over the past 5 years or so, is that getting over that initial planning and design phase in clean energy, resilient energy projects, especially now that energy upgrade projects are becoming more holistic in nature, like you're not doing just solar, you're not doing just efficiency, you're not doing just batteries, you're looking at the whole picture and you're moving forward with a comprehensive energy capital improvement project. And since that's the way the landscape is going, we're hearing that getting out of concept through planning and design to shovel ready is of course very expensive, especially when you're talking about large systems like multi-building microgrids that span a campus or something of that magnitude. And so seeing that this was an area of need for incentivization in the energy industry, seeing this as a common hurdle that we want our various organizations across Maryland to obviously surmount so they can get to actionable implementation, we wanted to respond with a grant that would address this need. We, of course, along with everybody on this call, had no idea that COVID was going to happen. And so, of course, over the past year, everybody's budget took a huge hit. So even more so now than ever before, there was a need for this type of investment because people just did not have free capital lying around. That was true before COVID, but especially true during COVID. So Resilient Maryland came in and gave these organizations grants to help get through that pre-construction planning process. And so that's how we arrived here. Next slide, please. So it's structured under 4 different areas of interest. So it's based on the scope, scale, and complexity of the DER, or Distributed Energy Resource, or DER system that you're looking to analyze. The first and by far most popular one, as you can probably imagine, is the community and campus microgrid projects. So those are the ones that have multiple facilities. You're on a campus or like a community configuration like the Fairmount Heights grid. These, of course, carry a very high price tag because you have to analyze a lot of different parts. You've got a lot of different DERs, a lot of different interactions, a lot of things to consider. And so that's why you can get up to $100,000 for those projects. Coming down from there, the Resilient Facility Power System, that's the same microgrid concept, but scaled down to just one building. I like to point to the Montgomery County Public Safety Headquarters as an example of that, which is what you see in that photo in the background. That's that building. It's got a few different DERs, solar PV, CHP, and a microgrid control system. So because they're a little simpler, $25,000. And then the last two, advanced CHP, that's combined heat and power that simply just has black start and islanding capability. So pretty straightforward, but you still need the cash to understand the project to make sure you're sizing it correctly. $10,000 for those. And last but certainly not least are resiliency hubs. So a resiliency hub is a centralized close by community location that community members can go to in the event of a grid outage, where they can receive access to power their electronic devices like phones and laptop computers so they can remain connected, condition space so they can remain in a safe, healthy temperature, refrigeration for temperature sensitive items like medications, and of course plug load capacity for essential medical equipment that's portable like CPAP machines, dialysis, what have you. They're not meant to be like full-scale emergency shelters, but rather a place people can go that's close by until the grid outage situation mitigates or proper emergency response arrives. And those are $10,000 per project because they're usually just a solar PV and battery storage system. And so grantees use these funds to create, a set of planning deliverables that will help them get from concept to shovel ready. And typically, those are the 5 that you see before you. We have flexibility in the program. If they present a different deliverable that they say is going to get them closer and they present a good case, we can do that. But typically, these are the 5 that we advise grantees. This is probably what you want to do. That's the feasibility report. So that's your traditional comprehensive feasibility analysis that shows what what the project is that you're looking at, how feasible it is, what configurations you might consider. Preliminary engineering data and designs. So that's for preliminary modeling, design, a 20-year pro forma financial model. So you can understand how all of the different, what all of your costs are, what your capital recovery looks like when you become cash positive. That helps paint the picture of risk for third-party capital providers, which is very important because you want to get favorable financing terms. And this is the document that will help that. Then greenhouse gas reduction analysis, as well as analysis of barriers to implementation. So that could be things like geographic barriers, regulations that might make things a little hard to navigate, just so you understand what hurdles you need to get over. Next slide, please. And so how have we done with this program? So we've run 2 years of it so far. I say 2 years, it's only existed since February of 2020, but the state runs on a fiscal year, so it's kind of off with the calendar year. So in FY20, the inaugural year, we have 13 projects that we have awarded and are working on their designs coming to completion. In FY21, you probably saw circulating in the energy news, we announced 8 more this year. And we really see an entire cross-section of our state's economy in terms of recipients. Everybody can benefit from this type of resilient investment. Critical infrastructure, of course, speaks for itself. Essential government services, low to moderate income communities, agricultural entities and food production facilities, regional planning, and many, many others. Our portfolio really is as diverse as I'm saying. So together, these 21 awards, they represent a little over $1.5 million in state investment in this type of analysis. And so not only will the grantees be prepped to get from concept to shovel ready, but MEA will also gain very valuable surface level granular information on what's happening in the energy industry and where market shortfalls might lie, so we can even better optimize our programs and consider possible policies in the future that can help mitigate common issues. So MEA gets something from this analysis, as do the grantees. Next slide, please. So before I transition over to Stephanie for a more comprehensive discussion of the project, there is one more component of this project that we're really excited about. It's going to give us the Fairmount Heights microgrid, that is, it's going to provide opportunities to learn about consumer behavior when they're presented with information about energy availability. And let me explain what I mean by that. So when the grid goes down, this configuration is going to incorporate an app that homeowners can elect to install on their phone that will let them know when the grid is down. And when they get notified, they also have the ability, if they'd like to go to a portal online that Amera is going to develop so they can see what their battery capacity and what the energy availability of the microgrid is. And when primed with that information, if they know they have a limited amount, it's going to allow us to see if they change their behavior, and if they do change their behavior, what they do. Let me stress, it is strictly voluntary. This is not something that they are being forced to do. This is something that they can elect to do. And they will be surveyed annually on if they were notified and how they modified their behaviors, if at all. So we're trying to understand how much being given the information incents somebody to change their behavior. Next slide, please. And that's all I have from the MEA side of things. I'll turn it over to Stephanie because she'll be able to give you a much deeper view of what this microgrid is going to look like. Thank you very much. I appreciate the opportunity to speak with you all today.
Hi, thank you very much, Brandon. So again, Stephanie Prestol. I'm the Deputy Director with Housing Initiative Partnership. We call ourselves HIP for short. Next slide, please. And we're just going to talk about the specific project that Brandon was describing. Go ahead. I have a lot of slides, but I'm fast. HIP is a nonprofit affordable housing developer and counseling agency. And we've done a lot of work with green and innovative housing development because we think it's very important for our low and moderate income communities to have those benefits as part of our larger initiative for secure housing. Next, please. So HIP is, as I said, is a developer and counseling agency. And with development, we are building or renovating multifamily communities such as these. Next slide, please. We also work in home ownership. So we will build new construction homes or renovate existing homes for home ownership opportunities for households earning 80% or less of area median income. Next. And we are also a HUD certified counseling agency. So we have counselors that provide a wide range of services in homebuyer education, foreclosure counseling, rental counseling, financial capability. Next, please. So this particular microgrid project is located in Fairmount Heights, which is in Prince George's County, Maryland. This just gives you a little bit of a perspective if you're not familiar with our area. Next. It is a small incorporated town that is historically African-American. It was incorporated in the early 1920s. And several years ago, they did an RFP because they have this particular lot in property in their town, which has this municipal shed that they use for maintenance, but they wanted to sell the property and work towards home ownership. And so HIP, our organization, responded to that RFP and ultimately won to be able to put 6 homes on this site. Next, please. We are working with, HIP will act as the developer. We're working with Peabody and Fine Architects, with the MEA administration that we just talked about, the Maryland Energy Administration. PEPCO is our local utility company, and Amera Technologies is an innovative energy company that is leading the way with some of this new technology around Blockbox that we're going to show with this particular project. Next. So this is the site plan. So, we're an affordable housing developer. We went into this looking to do efficient, net zero ready, maybe passive house design homes. We were going to put these 6 homes on the site. We were really excited about it. And our architect has really been pushing us to think even more innovatively about microgrids and has been working very hard and helping us with those partnerships in the energy community and with MEA and the Resilient Grant. So when we started this project, we were really looking at it as simply affordable homeownership. And then we've had this opportunity to add into this the design of the microgrid. At the very southern part of the site plan, you'll see this central block, and we'll talk more about that. That's the central location where that has the main storage capacity. Next slide, please. So this is just a rendering of what the homes will look like from the street. Next. So this is the main map of how this microgrid is going to work. Again, we're working with Amera Technologies. This is the innovative system that they've developed. You'll see that we have the home. There's the solar rooftop, and then it connects to the individual block box that's at each home. That will then connect to the block central on your far right. That is the central location where the main storage is. Maryland is deregulated, so we have a little more infrastructure. So our utility cannot generate and distribute power. So this system will ultimately be owned by Pepco. So we're creating, to allow this from a regulatory standpoint, we're creating community solar. So the energy will be created by the solar rooftop. It'll be distributed and stored in the central block. It'll be metered, and then it will be distributed back to the homes for use. And I am the housing developer with my own housing expertise. I am very quickly learning the microgrid world, and I do have folks from Amera on with us as well if people have more technical questions about the system and the distribution of the power. But we're very excited because this is going to be resilient. It's going to be clean energy. It's going to give more sustainability to our homeowners. The community itself is very excited to have this innovation in their community as well. Next slide. Here's a 3D rendering, and that central block is again that small little lot on the far right of your screen. So when you're working in a residential community, one of the things we were very concerned about is that you're adding infrastructure to a community, and a central block is somewhat large and maybe not the most attractive thing for a residential community. And so how can we creatively work with that in this existing historic community? And what we were able to do is we were able to divide the land in such a way that we're creating a pocket park where that central block is. We will shield or screen the central block from the visual street view by creating an attractive shed-like structure around it. And if you go to the next slide, with this pocket park, this is a historically African-American community that already has an African-American history walking tour through its community, but it doesn't really have a welcome center. So we are also going to turn this into the welcome center for the African-American History Trail. We'll have a map on site that shows all of the different points of interest in the community. There'll be seating. It'll just be a small area that is a meeting place for people to learn more about the history of the community, as well as somewhat hides and screens the central block from the rest of the residential community, so it doesn't stand out. So we're really excited about being able to incorporate affordability, new homes, a small pocket park, honoring the history of the community, and really bringing equity and energy to Fairmont Heights. So the other thing is, innovative piece of this is that we're building these homes modular. So we did a passive house that's very similar to this design in the same community many years ago. And these are just some pictures of the modular construction. So next screen. This gives you a sense of what the home looks like complete. Next. And some just interior photos. So it's light filled, all the low flow faucets and non-emitting VOCs of products in the home. So they're really comfortable, clean air, indoor air homes that our homeowners will really appreciate and will be easy to maintain going forward. So that gives you a sense of what the end product will look like. And that's my contact information.
Hello, thank you very much for having me. I'm Sequoia Cross. I'm the Chief Operating Officer for SimpliPhi Power. So next slide. Today I'm going to talk a little bit about what SimpliPhi is doing to serve diverse community needs with microgrids. And next slide. So a little background on the company. SimpliPhi was originally founded in 2010 as Optimized Energy Storage in Ojai, California, and our roots were in the film and broadcast industry. And we leveraged over a decade of experience to scale this proprietary technology and our proprietary technologies in manufacturing into the residential and commercial sector for key global markets, both on and off grid. Since our beginnings, we've only utilized LFP battery chemistry because we believe as a renewable company that it does not make sense to store clean energy in toxic batteries that contain cobalt and other questionably sourced materials, and fundamentally put customers at risk. And as the company continued to grow and scale using this safer chemistry, we had the opportunity to work to test the efficacy of our technology with the military. And we went through rigorous testing at the Aberdeen Proving Grounds. And further in 2013, 2014, we continued to scale and create larger, fully integrated units that provided a more robust and longer duration backup power and expanded our military and emergency response solutions. And around this time, our first Phi battery, there's some behind me, became available to the market for scaling on and off grid systems. And in 2015, we relaunched as SimpliPhi Power and continued to test our battery solutions and our non-toxic battery chemistry, and it introduced fully turnkey pre-assembled, pre-programmed access units for both residential and commercial applications. And this product continues to provide benefit in utility planned and unplanned outages in California and across the US, and provides distributed storage assets to customers. And most recently, we've continued to build our platform of scalability in addition to our product line with our Amplify battery module. And our intent is to continue to blur the line between utilities and customers with closed loop communications that can optimize battery storage for demand response programs and provide functionality for DERs and DERMs. Next slide. So SimpliPhi's mission is to create access to safe, reliable, and affordable power, and it's resulted in a robust product line that targets all aspects of the storage value chain. And by leveraging safe, non-toxic, non-hazardous cobalt-free chemistry, we eliminate the risk of thermal runaway with fire propagation. And as a company, we've gone through all regulatory testing, UL 1973, 9540, and 9540A on our batteries and systems. And our products have endured more lab and field testing than any other battery product on the market today, carrying all those UL certifications, UN DOT certifications, and special permission by the FAA to airship globally. So we believe with over a decade of experience in growth and over 100 megawatt hours of systems in over 40 countries, we can demonstrate the social impact and profitability coexist. Next slide. So just a little bit addressing the problem. One of the problems that we're facing today, or many of the problems we're facing today, is limited access to safe, affordable, and sustainable power. And escalating energy costs, as we all know, throughout the world are creating a dynamic that makes access to affordable power harder and harder to obtain. And in the US, electricity prices have risen over 15% in the last 10 years. And these increases are expected to continue. And utilities across the nation have been instituting more complex time of use rates and surge pricing during key points of the day, typically in the evening hours when solar isn't producing. And by incorporating battery storage, it can optimize solar production for utilities and help realize more levelized costs for homeowners. Next slide. So I wanted to talk a little bit more about the collaborative effort that SimpliPhi has taken in between resilient energy and communities. Next slide. So a project that we were really excited about, and we've had the pleasure of working with new partners, Community Solar, Jubilee Housing, and Pepco on the Exelon Microgrid at the Affordable Housing Resiliency Center in Washington, D.C. And one of the challenges was being able to provide enough was being able to provide resilient, affordable housing and community services in a rapidly growing LMI area. And the complex supports not just residences, but a teen drop-in center, a family resource center, an early childhood development and education program, as well as low-cost food market. And as the hub of the community, it was really important to focus on the affordability and equity during the project development. So everything from the beginning all the way through. And this project needed to not only pencil out financially, but the resilient benefits needed to be shared amongst all of the stakeholders and the stakeholder communities. And because of this value stacking, these projects can have significant financial benefits to the communities they serve, as well as the developers. Next slide. And so this was one of the first centers that was able to provide power for 3 consecutive days during a grid outage. It includes a 70.2 kilowatt rooftop array that's sited at one location that had the best solar resource, as well as 56 kilowatt hours of SimpliPhi batteries that are sited separately, and the system could seamlessly disconnect from the grid to provide backup power. And this emergency hub for the community saves customers an additional $40 to $50 per month through solar credits that are realized across the site and levelize their utility costs. And by having the storage sited at the location where it was needed, better resilience could be realized. And the system can easily in the future be modified to provide time of use, peak load shaving, and more grid interactivity, and become part of a larger aggregated network of systems. Next slide. So the Ludlow Taylor School project was one that we're just wrapping up. And this project was originally designed as a grid tie feed-in tariff system that was able to sell back 30% of their overproduction to Pepco. And it was originally installed in a rapidly changing neighborhood that had rising housing costs. And once COVID hit, as Brandon mentioned, the system's production far exceeded the loads present on the site due to the closures of the school. And they started to get into a losing proposition on the ROI. And so the school's location is in a closed area network, and it resulted in substantial credited production deficits. And they can only export to the community renewable energy facility the amount of electricity equivalent to a limited amount over the loads present at the site. So when that amount is exceeded, the system is actually turned off and all grid power ceased. And unfortunately, the CREF is only credited with a small fraction of the actual solar production. And so without intervention, the solar could end up costing the school money due to the NEM regulations and almost eliminated the payback time. Next slide. So what we were able to do was go in and retrofit the system with a high voltage storage solution. And they're able now to store the excess power generated during the day, and they're able to avoid the disconnection of the system. And in addition, they can now export the amalgamated daily amount of stored energy to the grid each night. They're currently working with the utility to model a new matrix of thresholds to maximize this ROI. And this has also created resilience at the site, the local community, by enabling the utility to access that stored energy and provide it to the surrounding communities. And we hope that it serves as a model of community-based solar plus storage projects that can then further be aggregated and used for peak load shaving, resilience, and grid stabilization. So next slide. So how do we bring resilient energy to LMI communities? So some of the challenges that we have found that these communities face is that many are under-resourced, underfunded, and overlooked by utilities, some policies, and local authorities. That seems to be changing, which is great. And many of these these communities' energy consumption is already limited, which is sometimes misaligned with project strategies that focus on offsetting larger usage and modulating load. And currently, there's no clear dollar per kilowatt value tied to resilience. We know it's valuable, but it's really hard to monetize. And however, at the local level, resilience losses due to both planned and unplanned outages are more economically damaging, and resilience can provide the peace of mind that these communities deserve. And we find there are a lot of growing opportunities in the LMI sector for microgrids to serve a variety of purposes, from resilience to levelized utility charges, credits, and rebates. And collaboration with community leaders, local utilities, government officials, and local installers does create a network of stakeholders that are all equally invested in the success and positive outcome of these projects. And the most cost-effective way, at least in our experience, to create LMI projects is to think about the future needs at the site. So not just planning for where they are now in the case of Ludlow Taylor, but really thinking about what is this community going to need in the future. And we do feel utilities have the ability to open up these markets and allow for more distributed assets that can be deployed as a mesh network of systems to realize resilience on a larger scale. Next slide. So a couple policy things. So there are a number of policy challenges currently facing microgrid deployment across the country, which are hindering implementation. There's a lack of microgrid or ESS tariffs, which fail to monetize the grid benefits that microgrids can provide. And because of this, developers are not seeing a clear financial benefit to getting involved all the time in these projects. And hopefully that's changing. I think Brandon has some really great points and a really great program. In addition, many of the utilities are implementing these standby charges or other punitive fees on microgrids and related DER equipment, which has further discouraged deployment. As I mentioned previously, there isn't currently a value associated with resilience and with the resilience that microgrids can provide and what the localized resilience is worth, and how those that support grid reliability should be compensated to prop up the utility. And additionally, microgrid classification has been pretty blurry. Sometimes they're defined as generation, which creates conflict with how utilities see site owners and how they should be compensated for the value they add. Across the country, however, as you can see in this map, there have been some states that are more favorable to microgrid deployment. California, New York, and northeastern states increased legislative activity supporting these projects. And in those states, you can see the increased deployment of these assets. And in 2020, last year, SEPA made suggestions on how utilities could successfully deploy microgrid services tariffs that would encourage growth and create a pathway to monetization. Additionally, many states have created policies that are in support of microgrids. SB 1339, which was a bill enacted in California in 2018, sorry, really directs the CPUC in consultation with the CEC and California ISOs to undertake a number of activities to further development policies related to microgrids. And Hawaii as well, they really observed that Hawaii's residents and businesses are vulnerable to disruptions, and that microgrids can provide that resilience and valuable services to the grid. And they've started to develop programs, as has Maine, LD 13. They're one of the ones that further clarify that microgrid operators are not utilities and directed regulators to approve up to 25 megawatts of microgrids that could serve the public interest and requires that microgrids meet state RPS targets. So next slide. So in close, by leveraging renewables and decoupling supply and demand for on and off grid use, we can accelerate the energy transition while reducing atmospheric CO2 and greenhouse gases, which are drivers behind climate change. We can reimagine this power grid, supporting new and emerging energy markets and technologies that blur the line between in front of and behind the meter assets, aligning the interests of utilities and customers. And by working together, we can create a more resilient power infrastructure using distributed customer-sited assets along the entire distribution grid for individuals, businesses, and whole communities. All of this can deliver economic value by eliminating the economic losses due to power outages and reducing daily energy costs through demand charge management, peak shaving, and time of use charges. So with that, next slide. Thank you very much. This is my contact information, and thank you for having me today.
Thank you to all of our panelists. Kirsten, do you want to start with the questions in the chat first?
Yeah, happy to. We got quite a few questions on the Fairmont Heights project. So I will start with those. One question is, how is the stored energy going to be controlled and managed so that equal use of it can be achieved without anyone running dry the batteries? And Stephanie, I will promote Chris or allow Chris to talk in case Amira wants to chime in. Okay, Chris, you should be able to unmute yourself and speak.
Okay, folks, can you hear me okay?
We hear you great.
Great, thank you. So thanks for the opportunity to speak a little bit about our technology there. Could you just repeat the question briefly again so I make sure I have the exact wording there right?
Absolutely. So the question was, how is the stored energy going to be controlled and managed so that not, there's no running dry of the batteries, that there's equitable access to the stored energy?
Sure, great. Thank you for the clarification. Yes, Smart System works as an integrated platform, and as both Stephanie and Brandon mentioned, it is actually having home in one of those block boxes that kilowatt hours of storage dedicated to that particular home, and then there will also be approximately 100 kilowatt hours of storage centrally located, that it's a shared resource across all of the homes, and it effectively works as an integrated network. So there's a controller, distributed controller at the central location as well as each and every block box. As a result of that, it's continuously optimizing the use of that energy. It's responding to changes in
I think we might have just lost Chris, and I apologize for the audio issues. I think he also had a little bit of a cutting in and out. I don't know, Stephanie or Brandon, if you wanted to add anything while we're trying to get him back.
I believe Manny is also a participant in Barrera.
Give me 1 second while I try to promote him. Okay, Manny, you should be able to talk now.
All right, great. Can you guys hear me?
Yep.
Yep, all set.
All right, great. Yeah, well, I think Chris was starting to describe, and just so I can understand the question, it was about how there can be equitable distribution across all participants and all homes within that microgrid system. And what Chris was starting to describe is kind of how that battery storage configuration is set up and networked. Each home will have approximately 18 kilowatts of battery storage on site at each home within what we call the block box. And then down at the block central, there'll be about 100 kilowatt hours of battery storage in the what we call the central, the block central, that's going to be right behind, in that pocket park that Stephanie showed earlier in the presentation. And what's within each block box, and these are all networked together along the right-of-way, interconnected with each other in the microgrid in a network. And each box has power electronics that manages the energy flow and control and storage and prioritizes it based on basically what the hierarchy of prioritization can be selected by the user in collaboration with the user being Pepco, because it is a Pepco system. So if we wanted to optimize certain aspects of it, the systems and the power electronics would cater to that. And I think that's where we would make sure everybody got the energy they needed and nobody that was left short. End of the day, this system is basically in front of the meter. So as the end user, they just see it as a, they just, receive that power bill from Pepco for the energy they used. So it's going to be there to support whatever energy consumption is needed for each individual evenly, and is not going to, distinguish or prioritize one individual over another. It might prioritize electrical sources, like let's say perhaps the grid power is long. It's there's excess grid power. We can charge the batteries with that grid power, or perhaps the grid is running a little bit short. We're running a little bit long on our battery storage. We can export back to the grid as a resource, like Stephanie indicated earlier. That's the thumbnail summary. There's a lot more detail behind that, but hopefully that addresses your question.
I believe so. I think there were a couple more questions on the batteries. So what is the duration of the battery? I think somebody said it was an 18 kW, but is it like a 2-hour battery, 4-hour battery?
Oh, well, it's a 18 kilowatt hours. So it depends on the load. If it's a 18 kilowatt load, which is really high, it's going to be 1 hour. But if it's a 2 kilowatt load, it'll be 9 hours.
Mm-hmm. And then maybe this is a question for Stephanie. As the microgrid project was developed in Fairmount Heights, how was the community engaged, and was their feedback incorporated in the design of the project?
Yeah, so like I said, originally when we started the project, it was affordable homeownership. So our community engagement started from the homeownership standpoint, the design of the homes, making sure that the community bought into the fact that the town wanted to sell the land to have new homes. So we did have engagement with the community in that regard. As the project has progressed and we've had the ability to add this microgrid component to it, we've had conversations with the city, or the town and their town council. We've had conversations with their various community subgroups. And then as it turns out, the Civic Association president is our neighbor on that street. So we've had lots of conversations with the Civic Association as well to just talk it through. And I think that they have been really willing to understand and have asked great questions, and are pleased with the inclusion of their feedback in the project. The reality is that particularly with the screening of that block central, that makes a huge difference because we're providing an amenity to the larger community with the pocket park. And we're screening what was a concern of ours of a large piece of infrastructure in the middle of a residential community. So, and I think they further appreciated that we were further celebrating the history that they're so proud of in their community. And so really engaging in that process as well. So all of those pieces were really important.
Great. And maybe this is a question both for Sequoia and also the Stephanie or Manny on the Fairmount Heights, but could you speak a little bit more sort of on what the terms are in terms of blue sky versus outage, like what kind of agreement and terms are involved? I know that, these projects have a lot of resilience benefit, but if you could kind of speak to maybe what happens in the blue sky versus in a outage situation.
Yeah, from a settlement structure, Stephanie, I don't know if you want to address that. In terms of how the system is operating for us, it's either you're going to sell back excess power that you're generating from a blue sky operation. You can remain and do time of use and different peak load shaving and really optimize the battery storage for various purposes. And then the systems that we design automatically roll over in an outage to provide resiliency. And then we design the system based on the site to provide a certain level of outage protection. But it does vary from project to project, and really what their pain points and the goals are of that project, as well as the financial models that are in place to support within that area. So I don't know, Stephanie, do you want to add anything?
I don't have much to add. I don't know, Manny, if you have anything to add.
Just a quick point that the system that we're deploying in Fairmont Heights is essentially an islanded microgrid. So in terms of reliance on the grid, when that goes down, it's just going to be one less asset that the system will have to choose from as it's making its energy delivery decisions.
Yeah, and really what we're finding with microgrid deployment in general, such dramatic changes that have happened in the last few years, as we see so much innovation on the software and controls side, and what these systems can do for communities, but also just for the owners of the systems. You know, before it was pretty much you're either doing backup or you're providing some amount of excess power that's going back out into the grid and realizing savings that way. But now so much more sophistication and AI that's going into these systems so that you can create a network of systems that talk to each other, that can aggregate those resources and then push them out as the load demands change from location to location.
I'd like to ask, I think, sort of a follow-up question to that, Sequoia, but this is really for anyone on the panel and maybe directly for Brandon. I think it was Brandon who mentioned an app that the consumers can download to be more personally involved in the system. And out in my part of the country, we've been focusing a lot on Texas and what's happening there. And recently there's been press about thermostats being controlled remotely and consumers not understanding that they signed up for that innovation. And I just wondered if someone on the panel could speak to how you're working with the consumers to make sure that they understand all of this technology and that they can really take advantage of it.
Thank you, Commissioner Throne. That's a great question. I'm actually going to defer that over to Stephanie or the folks at Amera, just because they're more in tune with how that app is going to be integrated. What I can tell, Pepco is going to be the one, from as we understand the project, is going to develop the app. They might be able to speak more to it. But what I do know is that it is strictly voluntary. But Stephanie, I don't know if you want to add any more to that question, because I think you know more.
So what I would add is, I mean, we're still in the design and figuring out all of these various components, but a piece that's been very important to me and that we talk a lot about as a team is the education piece, because we are providing we're an affordable housing provider, and we love to have innovation to make things more resilient and energy efficient. But at the end of the day, the purchaser who is buying our home has probably never experienced this technology, and they're a first-time home buyer, really excited about their home. And so we have to figure out a way to clearly explain and be available and have, you know, graphic manuals for me too, to be able to understand what the technology is, where their responsibility is as a homeowner, what is taken care of because it's part of a larger utility system, and what that means for usage and how they can benefit from it. And there are opportunities where, by knowing how they're using power, they might use it differently and have some savings. So we really view this as a real education process, and it has to be built in to the sale of our homes. And while once you sell the home, it is the homeowner's responsibility, because we are a nonprofit, we are not going away. We're in the community too. And so we look at this as an ongoing education piece. So we hope to have a longer term relationship with our homeowners on that education. It's so critical.
Yeah, I don't know if did anybody else want to speak to that, Sequoia?
Well, and I can definitely say, even from a battery storage perspective, as a manufacturer, we get heavily involved all the way through the educational process, the training process. And every day we're finding more and more homeowners are understanding energy usage in a different way and understanding load in a different way. I've been doing this for 15 years now, or over 15 years, and just a dramatic shift in renewables, how they're integrating into people's lives, and even these apps. So we work with a number of different software companies to help optimize our systems, and everything from residential, where people can turn their loads on and off depending on an outage. They know how much battery capacity they have left, how far that's going to take them based on the load. They can change the dynamics of the system based on the tariff rate from the utility, and really start understanding how they can become more integrated with their system and how they can change their energy usage in a more positive way.
Thank you.
Yeah.
It's a great discussion.
Great. Yeah, with that, we're at the top of the hour. So I just wanted to thank you so much to Stephanie and Brandon and Sequoia and Commissioner Throne for the moderation. I think this, and of course, Manny.
Yes.
I think that was an excellent discussion, and I really appreciate all your insights. With that, we will conclude the webinar portion. Again, thank you to the Office of Electricity, and I would just like to ask all the non-members of NASEO NARUC's Microgrid State Working Group to drop off. We will now close the meeting to just members only.
Thank you.
Great.
Again,
Thank you so much.
Thank you.
Thank you.
Thanks, everyone.
All right, thank you, everybody.
Thank you. So I'm just going to wait a couple seconds. I will also stop the recording.